Now let's discover the last C++ cast. We saw in the 3 previous videos the static cast, dynamic cast, and reinterpret cast, that none of these casts was able to do a transformation of the type qualifiers. Of course, the last cast, the const cast, is a C++ cast that will allow to make this operation. Let's have a look at a little example to see how it works. You'll see that it's very simple. In our case, we have what we already saw in our last video on Ccast, in which I was talking about the types qualifiers casts. With const more particularly, the const cast will replace the semantics of the Ccast in C++. The context is the same. We have the same reference value, which will be a integer initialized to 42. I'll make an implicit promotion of my a address to a constant integer address. Here we're moving to a more generic type from a more accurate one. Remember, the notion of generic, accurate isn't really the best when we're referring to a const, since it's not the same notion. But we'll say that const values are higher than mutable values. Then going from a mutable value to a constant one doesn't cause any problem, which means that we'll have a promotion of value. Then we saw that due to the semantics of const, the opposite was impossible. It means that if I wanted to make a demotion, going from a constant type to a non-constant type with an implicit cast, the compiler wouldn't allow me to, of course. That's still the case in C++. And this line, by definition of the const, won't be compiled. C++ introduces a new cast, the const_cast, which will allow us to make this change of type qualifier. The syntax is still the same. We're using the const_cast keyword, and then we'll write the target type between chevrons. And we'll write the name of the expression we want to cast in brackets. Here my b value is a constant integer pointer. So I want to transform. I want to constcast my constant integer address to a mutable integer address. I'll be able to do it using the const_cast. And here we can see that this line in particular will be compiled in the same way that I warned you about the cast of type qualifiers in the C video. Here in the C++ context, it's still perfectly true. Using a const_cast in your C++ code is a very, very bad sign. It usually means that your design is wrong, and you'd be better off reworking your code and transforming it to avoid this const_cast. While keeping in mind that you should keep as many value constant as possible, this will make your program easier to maintain and more stable through time. However, if you have to make a const_cast at some point, do it, but make sure you have a good reason. Of course, laziness isn't a good reason. Let me remember you the example with the library. If you have to use a function of a library, of which a parameter should be constant according to the semantics of the function, but the developer forgot to do it, you come with your constant value that you can't use. Sorry, I mean the other way around. 338. Anyway, you may use const_cast in this case. The point is you must be aware of what you're doing. And if you're using a const_cast, make sure that it's not because of a design flaw. I won't linger any longer on this notion. It's quite simple regarding both the semantics and the syntax. That's the end of the introduction of the different C++ casts: static cast, dynamic cast, reinterpret cast, and const_cast. Next, we'll see a few additional notions on casts. In order to reinforce the notion, we'll finish with a conclusion of the course. I'll see you very soon.